All right, that was one skills number 36. We're going to use the quadratic formula. So the quadratic formula it looks like this, and it is derived from completing the square on the standard form for a quadratic equation. Okay, so here's the standard form for the quadratic equation. Make sure you have an equals 0 before you use it. And then you're going to use A, B, and C. A is the x squared coefficient, B is the x coefficient, and C is your constant there. Okay, it can be used with any quadratic equation as long as you are in standard form. Now, we've learned other methods like factoring to solve also, and factoring is usually easier, but the quadratic formula will always work. That's the advantage of it. So as a first example, this is a quadratic equation. We are in standard form because we have this equals 0. Okay, so we identify A, B, and C, A being the x squared coefficient, B being the x coefficient, and C being the constant. Okay, here's the quadratic formula. Notice it's color-coded. Notice also I put these parentheses around B. The biggest mistake I see is when you have a negative B, which is not the case for example 1, but when you have a negative B, if you neglect to put that in parentheses, you're going to be off by a negative sign. It's going to mess you up. It's going to mess up this part in here. So make sure you put B in parentheses. And we went ahead and went all the way down with this one. But if you'll notice, we put the green 9 in for each of these B positions, the red 1 or A into each of these A positions, and the purple C in this position. And this is the way it ends up looking, and it may be kind of unsatisfying the answer here, but it's actually kind of nice. When you get the part under the square root and it won't reduce at all, then you get to your answer more quickly. You could change this to two different numbers by adding the square root of 89 divided by 2 and then subtracting the square root of 89 divided by 2. And in some cases, you'll need to do that. But if you're just solving naturally, then we tend to leave it like this. Okay. There's also questions as to how much do you want to do into the calculator. And calculator can be funny sometimes if you try to plug it all in there. One problem you'll encounter is you don't have a plus or minus button. Another problem that you might encounter is it may not give it to you in exact form. What's probably better or sometimes often necessary is to only put this part, which we call the discriminant, only put this part in the calculator because, of course, that's just negative 9. 2 times 1 is really easy to calculate. For a second example, notice this time we're not in standard form. The 5 is not over here with the other two, so we need to subtract the 5 to get that to happen. Okay, so make sure you have an equals 0 first. And without color coding this time, notice A is 2, B is negative 2, and C is negative 5. Again, be very careful when you have a negative B. A couple things happen. For one thing, this becomes positive. I didn't rewrite the formula this time, but x equals negative B. Since B is already negative, this is going to be a positive 2. Notice also, it's careful to put this in parentheses. Okay, if I'm going straight calculator here, you're going to need to put that in parentheses. All right, and notice again here that we have 2 just stays. 2 times 2 is 4. That you don't need the calculator for that. But this part right here, it's not hard to do without a calculator, but this may be the part you put in there. Make sure it's in parentheses. You get 44. But this is a little bit harder than the previous example because 44 simplifies. Let's check that out. Okay, here's where we were. You can simplify square root of 44 into 2 root 11. At this point, you should be able to simplify radicals. Of course, that's root 4 times root 11, which becomes 2 root 11. If we have a situation where all three of these numbers, okay, here, here, and here, are all divisible by the same number, we go ahead and divide it. Not the 11, because that's not, it's actually not 11, it's the square root of 11. But if each of these numbers are divisible by the same thing, we go ahead and divide it out. Okay, so they all divide to become 1. Now, I need to write this 1 because it matters when you add, but it does not matter when you multiply or divide by 1, so I didn't write this. A third example, again, this is not in standard form. Another tip here, it's very desirable to have a positive A. All right, so we've got that positive A there. Okay, we subtracted the x and subtracted the 7. This time I didn't label A, B, and C. B is negative 1. So what I did on this one was an alternate thing. We have a positive 1 here. Here I just went ahead and squared negative 1. I didn't say negative 1 squared in parentheses. I just went ahead and did that. I just said positive 1 right here. So that's an alternate way of doing it. A again is here and here. C is here. Again, this is the part you want to put in the square root. So we get 168, 1 plus 168 for that. If you're doing it by hand, this becomes 168. 2 times 6, of course, is just 12. Now this time, let's go to the next slide. That 169, actually, not only does it reduce it, it just becomes a whole number, 13. So you never want to leave it like this. If the square root disappears, what you want to do is go ahead and split it. Okay, the plus or minus, remember, that just means you're adding and subtracting both within the problem. So if I add within the problem, 1 plus 13 is 14 divided by 12 reduces to 7/6. If I'm subtracting in the problem, I get -1. Okay, so we'll leave that there, but 7/6 and -1 would be your solutions. Quadratic formula.